Okay, when we say Hadoop is up and running, we'll try to check how many daemons are running, whether all the services are running or not. How we will check? We'll use the command JPS. JPS is a Java processing services, like how many services are running, which is these are the Java processors, right? The Hadoop framework has been designed and developed by using Java. So these are ideally the Java services. So these are the daemons, right? So these daemons we will check by using the command JPS. So when you check JPS, it will show you all the demands. It has to show the 5 demands for, for the normal setup. When it comes to the HBase, and if you have any other tools like a Quorum or Journal, new tools are there. When you are working with them, those also will come under these Java services. That time you will be seeing more than 5 services. Now, for time being, we'll consider the first the basic or main 5 services. Without these services, we may not able to process the data. We can store the data with the name node. If you have a name node, data node, and secondary node, we can store the data. If you want to process the data, you should have a job tracker and task tracker as well. Okay, we will see one by one. Okay, fine. What is name node? What is name node? See, in the architecture, as I explained in the yesterday, name node is the master node, right? As I explained, he is like a team lead. He's like a team lead in the team who will manage the team members. And what are his roles and responsibilities? What he will do when it comes to the Hadoop? What is in what when it comes to the Hadoop in HDFS? What is the name node role, and what is it? What is the main purpose of the name node here? In the HDFS cluster, name node is a master node where it will manage the cluster. Managing in the sense it will be interacting to the data nodes, and it will be checking the data node statuses, and it will be scheduling the jobs, and it will be assigning the work, and it will be maintaining the latest state of all the data nodes. It will maintain the file structure in the tree form, right? Yeah. Is it clear, guys, about the name node? Okay, I'm repeating one more time. Name node is a master node in the HDFS architecture, and it will maintain the file system on naming space in the tree format. It will not store any data persistently. Data in the sense, what are the data we are going to process? It will store the data like data like edit logs in FS image format. That are the metadata, and the name node will maintain the states of the cluster or states of the data node in the form of edit log, and FS image. And those name node will maintain latest state in the RAM as well as persistent storage. It means your local hard disk in the name node hard disk. Okay, and the name node will be keep talking to the data nodes. I mean, keep receiving the status from the data nodes, and your name node will be assigning the task to data nodes when it comes to job tracker and task tracker. Okay, here the it will maintain the files. I mean, it will maintain the file status in a tree structure format. Means it will be like we'll be seeing, right. Let's assume I'm just giving you an example here. Root slash sample.txt. Same. We can sometimes we may see root slash like this, right? It means that one root will be there, under multiple subdirectories will be there. That is called a tree structure. Okay, in the RAM, in the name node RAM, it will be storing latest state like fs image, because it should be it should be suppose if anyone contacts it has to give the which are the data nodes has what data, which are the data nodes are running, where and all the space is available, all the information should ready with the name node. Those details will be there in RAM as well as in the local file system. Those files are like your edit logs and fs image. What is edit log and what is fs image we'll be seeing in the next slide. Is it clear guys about name node? Okay, could you please anyone know repeat what is the name node? This is very much important. We should know what is the name node, and we should know what is the roles and responsibilities of the name node. If you should be very you should be very clear about the architecture. Okay, I'll be repeating it for you guys one more time. Name node is a master, and it manages the file. It manages the namespace. It manages the file system in that, and metadata. It's a metadata in the form of directories in the tree structure, as I shown you the tree structure. Okay, now this information, that namespace, or it manages the how many data nodes are there, where and all the file to block or block to data node. This mapping will be stored in the name node. It will be stored in the RAM in the sense for to process for the live interactions, and it will be storing the same thing into the local hard disk. If I don't have the latest state in the RAM, how it will give the responses when client interact with them, right? So it will be keeping the latest state in the RAM, as well as it will be keeping into the local file system. That is the reason we need a name node which should have a high-end hardware. That is the reason if you in a cluster for the name node, our configurations will be more. I mean, it will be like a high-end configuration. It's not a commodity hardware. Name node should be a not a commodity hardware, because it is a failure single point of failure, right? If we lose the name node contact, and we cannot interact with the cluster. So that is the reason we should have a good hardware for the name node. Okay, your name node knows everything about the data nodes, like what is the current task is running on the data node, and it knows what are the blocks or what are the data has been stored in the name node, and it will be maintaining all these details in the metadata in the name node's memory, as well as persistent data, I mean persistence in the local file system. Okay, is it clear guys? We have 50017, right? I think it's sorry, I didn't remember the port number exactly. Yes, 50070. Okay, and what is a data node? Data node is a slave node in the cluster who will store the data in it, and who will actually process the data. It will be keep interacting with the name node, saying that I have this data, I have these lots are free, I am this much healthy. All this information will keep sending to the name node in the form of RPC calls for every 3 seconds. Okay, if didn't send a heartbeat to the name node within 10 seconds, it will treat it as the name node will treat it as dead node, and it will mark it as a dead node. When it comes when it I mean when it is again start sending that heartbeat, then it will treat it as a live node, and it will remove your name node will be maintaining one table like live node, dead node. So when the data node is not sending the heartbeat to the name node, it will mark it as a dead node in the uh, dead node table. It's ideally it's a table for your understanding. I'm telling it's a table. It will be maintaining some metadata. There it will mark it as a dead node. Okay, is it clear, guys? And what is the secondary name node? The name, it is saying that secondary name node. When we see this name, we'll think that secondary name node is a like when the primary name node fail, the secondary name node will take automatically the control. No, it is not the case. The secondary name node is for only the backup purpose. Not only it's ideally it's not only the backup purpose. It is not a backup node, I can say. What it will do, it will just merge your transactions, your edit log with the fs image, and again it send it back to the your name node. We will see in detail about the secondary name node, what and all it will do, and when it will execute. All the details we'll see in a coming slide. Okay, let's see what is a job tracker. Okay, job tracker is a service which is running with run on the Hadoop and which is running on the master node. Or job tracker, you can also say, is a master daemon. And name node, secondary name node, data nodes are the machines, I can say physical machines. And when it comes to the job track and task track, those are the daemons. Those are the daemon services where will run on the JVM. It's like a Java virtual machine. It's kind of thread. It's not ideally it's not a thread. It is a one service which is running on the backend. And when it comes to the name node, data node, secondary node, those are the physical machines. Okay. So why we need a job tracker and task tracker? When we want to process a data through anything like MapReduce or any tool, if you use any tool like your MapReduce or Hive, ideally at backend, it will assigning the task to, it will be assigning the task, right? Task to, it will assign the task to the data nodes. So when we are processing the data, when we are storing the data, we don't need the job tracker and task tracker. When we are processing the data, we should have a job tracker and task tracker. Okay, that is the reason I have asked one question sometime before. Without running the job tracker and task tracker, we can store the data in cluster. While for storing the data, we don't need the job tracker and task tracker. But if you want to access the data or if you want to process the data, we have to, I mean, the job tracker and task tracker has to run. If these two are not running, we cannot process any data. Okay, and what is the job tracker? What is its roles? Okay, as I said, job tracker is the master service which is running on the Hadoop and which will maintain the manage the cluster, which will knows the resources and which are the resources are free, and which will assign the task, to the I mean a slave daemons like a task tracker. Okay, and it will keep monitoring it. And your job tracker is responsible for the scheduling the job. Okay, so let's see the flow, how it will, when job tracker will start, how the task will be assigned. When your application, your client application submits the job, like when I said Hadoop jar and jar name, and you have submitted the job to the cluster, then your job tracker, then job client will be there, and it will be interacting with the job tracker, and it will take the job id, and it will that with the job id the whole the resources will be kept into the hdfs. And your job tracker will check the schedule, I mean assign the scheduler for the execute the job, and it will talk to the name node. And after talking to the name node, it will take the latest, I mean resources, what are the data nodes and what are the data nodes are free, I mean what are the data nodes are I have this data, and what where are the data nodes are slots are free. Okay, then it will assign the task to them, and it will launch the new JVM. Here, guys, if anyone asks that what whether work the job is launched on thread, if anyone says that the job is launched by a thread, no, it is not a thread. It's a completely JVM. Each task tracker will run on the JVM, not in the thread. Please remember that your each task tracker will run on the JVM. It is not launched via threads. Thread is completely different and processor is completely different. Okay, your JVM is completely different. JVM is a Java virtual machine. It will not launch the threads. It launch a complete JVM, because your data nodes your data node will be on JVM, right? Your data node will contain the JVM, Java virtual machine. There it will run the task trackers. Okay, once the job ID has been created, once it has been scheduled, and it will identify, it will talk to the name node, it will get the resources where and all the data is located, and then it will start launching the jobs on them. Okay, and also it will smartly identify that which see, we have the replication factor, and it will check which one is near, which one is near data node, or which where the data is very nearly. There it will start launching. If it's not able to launch, and it may go to next rack, so that will come into the we'll see what is a rack awareness later point of time. So it will try to launch the jobs in the same rack. If something happened or data is not available in the same rack, it will launch the job into the other rack. It's called data locality. And after assigning the task, those tasks will be monitored by your job tracker, and it will be keep checking what is the status and how much he has finished. If anyone is not able to finish, and your job tracker will launch the same job in other application. Okay, and it will keep receiving the notifications from your task tracker. It is a master service. Okay, when work completes, it will your job tracker will interact with the client, and it will inform that this job is completed. Clear about the job tracker? Very good question, Chandu. It's not like one job tracker contains how many task trackers. It's not like that. It's your when you submit the job. Okay, when you submit the job, how many mappers are required, how many reducers required will be calculated based on your input. Okay, and the reducer tasks we can specify, but mapper tasks will be decided by the your client or your splits. Suppose if you have 5 splits, there will be 5 map tasks will be running. You can assign any number of reducers for that. Depends on those map tasks, your number of task trackers will be calculated, number of task trackers will be launched. Okay, ideally these task tracks are running on your data nodes. It depends the task trackers, how many task trackers are running. Ideally it is like it may be the how many data blocks you have, how many blocks you have, those many machines it has to launch, right? Okay, if any task is taking more time, or if any task is taking more time, it will keep intimating to the job tracker. Is it your doubt is clear, Chandu? Correct. Each name node will be having only one job tracker. How many data nodes are there? How much data has been spreaded? Let's say 10 in 10 data nodes. I have a 10 blocks in that. I have a 10 blocks in 10 machines. It has to launch the 10 job trackers. Sorry, task trackers. In two job only, I have a even though if I have 10 data nodes, and my data has been spreaded across only three three machines, it will be launched with three job trackers. Internally, again, the map task and reduce task will be running, but wherever the data is there, there only your job trackers will be launched. Is it clear, Chandu? Okay, what is a task tracker? Task tracker is a slave daemon or slave service which will run on the data node, and it will process the data. It will launch the map tasks or reduce tasks. Your task tracks actually launch the map task and reduce tasks, and the task tracker uh, will execute. I mean, will process the actual data, and it is keep responding to the name node. Sorry, your job tracker. It will keep sending the status to the your job tracker. Okay, your task tracker is responsible to take the data, process it. Okay, so there is no much roles, no roles and responsibility of the task tracker apart from the processing the data and taking the data. Something, there's some in one machine the split has been the two blocks are there. The two blocks are spread into two data nodes, and the split has been calculated into one task. So both two blocks has been treated as a one task. Two data blocks has been treated as a one task or one split. Then it has to launch a map job on one split. So what it has to copy the data from other data node. So that also will be that's also one of the responsibility of your task tracker. Your task tracker only will take care of it. It will start copy the data from other data node. Mapper reducer is created by job tracker or task tracker. It will be created by your task tracker. Your job tracker only launch the task trackers. Map job and reduce job will be launching on the data nodes. So who will launch it? Your task tracker. Is it clear, Meghna? Okay. Is it clear about your all the demons? Shall we go move to next slide? Here the detailed information for each node daemon. What is a data node? It is a slave node. Data node can read and write the data into I mean, ideally it is in hdfs. Data node, when we say data node, it is there in hdfs. Okay, I mean, what is a hdfs? Hdf is a virtual file system, virtual layer on top of the local file system. Okay, so your hdfs contain one or more data nodes, and the data has been replicated across the cluster. So guys, you may get an entry question, why we need a replication. I have given example yesterday. So replication is more important for the speculative execution, for the I mean, fault tolerance, I can say. Okay, the data nodes are meant for storing the data, and the how it will store the data in the form of blocks. So what is a block? Block is a physical chunk of data. Clear, guys? And where this mapping will be there, file to block and block to data node, this mapping will be stored into your name node. Your name node will be maintaining this mapping. File to block and block to data node will be maintaining by your name node in the form of edit logs and fs image. What is a name node? As I explained, name node is a master node, and it will be keep interacting. It will maintain the it will maintain the metadata of your cluster, I can say, and it will be maintaining the file block to file and sorry, file to block, and your block to data node mapping will be maintaining in your name node. and this fs image latest state will be there in the primary memory, which is ram, and the same data will be available in the local file system as well. And what is edit logs and what is the fs image, I'll cover in the next slide. Edit logs are the raw transactions. If I try to access some data, if I write the some data, all these transactions will be going to the edit logs, and later it will be merged with the fs image. I'll tell you when it will merge and who will merge. Okay, as I said, so all the information will be stored in the main memory, as well as it will be stored in the hard disk for the persistent storage, like it for the future reference. Okay, for persistent storage, as I said, name node is the central point of of failure, single point of failure, I can say, in the architecture. So if it fails, we cannot interact with the cluster. Okay, if anyone wants to interact with the cluster, first they have to talk to name node only. There is no alternative option. They has to talk to name node. They have to get the resources from the name node. Like if he wants to write or he want to read, he has to talk to the name node only. Even though if you want to process some data, he has to talk to the job tracker. Job tracker will be is a daemon which is running on the name node. Okay, these roles and responsibilities are bit important, guys. You may get across the inter question. You may come across the one of the question from here. What is the job tracker roles and responsibilities, or what is the name node roles and responsibilities? Okay, what is the limitations of name node? So let's assume I have a cluster, big cluster. There are so many people are working on it. The people are keep interacting with the cluster by sending the putting in the data, retrieving the data. So for each transaction, it will be entered. As I said, each transaction, it means each transaction, when you put the data or when you receive the data, each transaction will be written into the edit logs. Like make entry, it will make entry into the edit logs. Let's assume I have done so many interactions. Let's assume I have done millions of billions of transactions. Our cluster keep running. It will not be down for some time, or it will not stop it for maintenance for some time. Right? It's a live cluster. To keep running. So when I do more transactions, each transaction will make entry into the edit logs. Then you will edit logs become a huge. Your edit log become huge. Then if edit log is become a huge large, again it's managed, it's a bit difficult to manage it, right? When it is restarted your cluster, something happened, or we have taken some shutdown time and we have restarted the cluster. When we restart the cluster, it has to merge with fs image. It has to load if fs image into your fs image into the memory. So to merge this, it will take more time. To merge your edit log with the fs image, the fs image will be there in the ram, not the edit logs. Edit logs will be only raw transactions will be there in our local file system. Okay, when your name node restarts, it has to merge your fs image and edit log. It will take huge amount of time because the edit log has the huge amount of transactions in that. To overcome this limit, our limitation of the name node, we come up with a secondary name node. What is the secondary name node? Secondary name node is a machine where periodically interact with the name node, and it will take the fs image and edit logs and it will merge it and will return back to the name node. Okay, if anyone wants to go through, you can go through the slide. Okay, it interacts to name node for every 40 minutes. It is not like 40 minutes, Chandu. We can configure it. By default is 1 hour, or if you reaches the transactions 1 million transactions, that's also configuration. By default, if you reaches the 1 million transactions, it will talk to the name node. I mean, name node will directly send to the the transactions and FS directly sent to the secondary name node, and your secondary name node will merge the FS image and edit log. There are two configurations. One is the every 1 hour. Other one is if you reaches the transaction 1 million transactions. If it reaches the 1 million transaction, we have to, the secondary name node will take the FS image and edit log, it will merge it and it will update to the name node. Okay, why can't we recover metadata and start running normal from secondary name node when name node fails? Okay, your name node will not store any your edit logs on FS image. See, actually, if you don't have the secondary name node, what will happen? The name node is failed. Okay, and our people will come, they will take some recovery tool, they have some recovery tools, they will try to recover the data from this FS image and edit logs from your primary name node only, and they will try to again merge them, that they will try to bring about the new machine, or they will copy this data into other machine, they will try to bring it up. It may take so much of time, it may take 1 hour, 2 hours, 3 hours, right? To overcome that problem, like to make a faster interaction, to make a recovery faster, we have a secondary name node. What secondary name node will do, periodically it interact with the name node, and it will take the edit log and FS image and it will merge it. There will be copy in secondary name node as well, but the secondary name node will never take care of the roles and responsibility of the primary name node. When the primary name node is failed and we will interact with the secondary name node, we will take that state till what state it has been updated and merged. We will uh, we will uh, we will bring back to the our name node with the help of the secondary name node. That's it. That is the only purpose we are using the secondary name node. Secondary, one second guys, one by one. I think Meghna has found out. Secondary name node also stores edit logs on name node RAM, and it's only right. See, secondary name node will not store any information in their primary memory. It will store into the its local file system only. It will take, if a secondary name node will interact with the name node, and it will take the FS image and edit log and it will merge it and it will give back to the name node. See guys, here when it comes to the secondary name node, there are multiple options for it. Like there is a backup node, there is a checkpoint node. All these are the secondary name nodes only, and there is a high availability. Okay, there is a federation. All these things come for the alternative for the secondary name node. Okay, we will see them one by one. Actually, this backup node, checkpoint node are come into Hadoop 2 onwards. To overcome this problem, ideally we have a problem where the name node is a single point of failure, right? Or if it is fails, we may not be able to interact with the cluster. If to bring it up, it will take some time, minimum 1 hour or 2 hours it will take, because we have to get the data from name nodes local memory, and then load into the primary memory, then load into the new machine, then we have to bring it up. To avoid that, we have a secondary name node where we'll get the where we'll take this. See, let's say in the name node you have stored some data, this is completely corrupted, you are not able to take the backup from the name node and failed name node. So from where we'll get the this backup, we will get this backup from the secondary name node. The secondary name node will not contain the latest, the secondary name node will not contain the latest transactions, latest FS image, right? It will be containing the old one. Let's assume last 1 hour I have done some transactions. Later I didn't do any transactions, or I have done some transaction with interaction cluster. Then my name node is failed. Will you be having the latest image in latest image or latest state in our secondary name node? No, we will not be having this latest image in or latest state in the secondary name node, right? So secondary name node will contain only the till what point? So till before, 1 hour before, or 1 million records, 1 million transactions before only, right? So then only it will come up. Okay, 1 second. Chandu has one doubt here. One doubt: we configure 40 minutes. After 10 minutes, name node fails. The transactions happened in 10 minutes. That will not be back up to the secondary node. No, that will not be back up to the secondary name node. They you have a some architecture changes in hdfs Hadoop 2, I can say, where these transactions will be stored into the primary name node in local memory as well. Those transactions will be there in your primary memory, I mean primary name node, like your name node local file local storage. We can when it starts, it will take that those transactions, it will merge with the fs image, then it will up the it will start, it will up no it will start getting the latest status, and it will no it will start, I mean, alive, it will start functioning. See, the name node, the secondary name node purpose is here. You just merge the edit logs and fs image. That is the only purpose here. If your name node completely dead, there is no, we cannot able to get any recovery. Then what we will do? We will talk to the secondary name node. We will get those information that is not the latest state. In the secondary name node, you will not have the latest state. You will be having some point of time, like last 1 hour, or let's say two. 1 million records, when it reaches 1 million records, that state only will be there. After that, what are the transactions happen, it will not be it will not be available in the secondary name node. We will be losing those information. Let's assume your primary name node is not failed, but just restarted. It has some problem, we have for maintenance, we just restarted. It is not failed, your name node is perfectly fine, but only for some purpose we restarted it. Then what will happen? It will contain the all latest state, and it will be having the latest transactions, everything will be there in the name node memory. When it starts the name node, what it will try to do, it will try to merge your edit logs with the fs image. To merge it, it may take some time to merge it, and it will also wait. 80% of the data nodes, or 80% of the data nodes has to report their blocks to the name node. They'll start reporting to the name node, right? Then once the 80% of the data nodes has reported them, saying that we have these blocks, we have these blocks, then your name node will come into functioning, I mean come to live, and it will start functioning. Till this state, it's merging and is waiting for the reporting 80% of the cluster, it will be in safe mode. This is also one of the interview question, why your name node will be in safe mode. We'll see in detail. Clear about the secondary name node, primary name node, and fs image and edit logs, we will see in detail. I'll show you that, what are the data will be there available in the fs image and edit logs. Are you guys clear about name node, secondary name node, and how the transactions happen? Other guys? Okay, I think someone has money. Anusha. Anusha, money. I mean, is it clear, guys? Or you want me to repeat? Or Okay, I think it's clear. I think these guys are not responding. I don't know. Maybe some problem. Fine, we'll go with the next slide. Okay, job tracker. We have already explained what is a job tracker. If anyone wants to go through it, please have a look. I'll just take some water. Okay, let me explain point by point here. Job tracker is mainly used for resource management. Not only resource management, for the job scheduling, for monitoring as well. Job scheduling is nothing but assigning the tasks, and it's, I mean, it's a, I can say when it comes to the processing, it is a main component. Like it's a master component when it's a data processing. It takes the user request to submit the data to, I mean, the task to the slave nodes, like who are all task trackers. Your your track your job tracker will keep talking to the name node and get the resources and assign the task to those resources. I mean, those data nodes are those task trackers which are running those data nodes. Okay, your task tracker will keep intimating or keep interacting with the job tracker, keeps telling that this is the job I have processing, this is the status, and these are the blocks are there with me. This all information will be keep sending to the name node as well as the job tracker in the form of heartbeats. And let's assume any task tracker is failed, or any task tracker or any data node is taking more time to process the data, then your job tracker will launch the same job into other machines which are available in the same rack. First we'll check in the same rack. If it is not available in the same rack, it will launch the same job into other rack as well. Clear, guys? Okay, what are the task trackers? What is the roles and responsibilities of the task tracker? Task tracker's roles and responsibilities are: it is a slave node. I mean, it can say it is a slave process which is running on the data node. Each task tracker responsibility is to execute the individual task into their data nodes where the data is available. Your job tracker will be assigning the work. Guy, you do this work, you do this work, you do this work, like that. Your job tracker will assign the work to them, and your task tracker will launch the map job and reduce job. If any problem with the map job or reduce job, any problem with that, your task tracker will keep intimating to your job tracker, saying that this guy, I mean, saying that this is the status of running of this job. This is the status of running of this job. Like that, your task tracker will keep intimating to the job tracker. Okay, if job tracker is not receiving the heartbeat from the task tracker, and it will be, I mean, some specified amount of time, that also can be configured. So it assumes that that data node or that task is crashed, and it will resubmit the job into some other machines where it is possible. That is the job of your job tracker. But your task tracker is responsible to intimate them, give the status to the job tracker. Is it clear? I think someone asked me the question: who will launch the map job and map task and reduce task? You can see this diagram where it will make you clear. See the diagram, and who is assigning the job track and task track, I mean map task and reduce task, your task tracker. Your task track will run on the JVM. Is it clear, guys? Is it clear? And okay, before going into this data flow, I want to everyone setup is should be ready. Then we will do some exercise. We will do one exercise, putting data, retrieving the data. Then we will go to the read flow and write flow. Okay, now I will spend another half an hour time to see each and everyone's setup. Once each setup is ready, we'll go with the practical thing: read flow, write flow, how we'll write, how we'll read, and all those things we'll see. Okay, guys, I'm stopping my screen share, and I want you to, any one of you, Anyone of you please share your screen. Then I'll see the what I'll see the status, like I'll see whether your machines are running or not. According to that, accordingly we will do the setup. Let me stop recording as well.